Hello, this video is part 3 from Measures of Spread. We're starting off on the slide titled Bell-Shaped Histogram. So if you look mid-screen, there is a picture of a curve that reminds us of a bell. This bell-shaped curve is actually representative of a histogram. So if you'll think back to when we did histograms, which is pretty recent, and just think of what a symmetric histogram looks like. This is not perfect by any means, but just imagine approximately symmetrical. Okay, so this curve right here is actually representative of a histogram. The curve itself kind of outlines the shape of the peaks. So the highest parts of each of the bars, it highlights that shape to kind of show us what the shape of the distribution is, rather than seeing a histogram every time. So you're going to stop seeing actual full histograms so much, and you're going to start seeing the shape of the histogram instead. Again, this is called a bell-shaped curve, and it represents a histogram. So if you'll remember, for these type of histograms, this bar here, this one, is the bar that represents the mean, the median, and the mode when it's symmetric like that. That was one of the characteristics of that type of histogram. So you will notice that we will be dealing with quite a few histograms that are bell-shaped in the future, or rather the bell-shaped curve. So because of that, we have some characteristics of a bell-shaped curve in the form of what is called the empirical rule. It's basically 3 characteristics that you need to learn that these characteristics are true for any histogram that's symmetric and bell-shaped. So there's 3 of them. The first one says that approximately 68% of the data will be within 1 standard deviation of the mean. So if you look here, there's a small number line at the bottom of your screen. You'll see in the very center, you'll see the symbol mu, which represents the population mean. So let's say that's in the center of the histogram. If I go up 1 standard deviation above the mean, that means I'm going to add a standard deviation. So you'll see mu plus sigma. And I get this boundary right here, this right boundary. And then if I also subtract 1 standard deviation from the mean, and I get this boundary, between those 2 numbers, that would be 68% of the data. That's true for all symmetric histograms. Okay. Now, if we go out 2 standard deviations from the mean, add 2 standard deviations, and subtract 2 standard deviations, those 2 boundaries will have 95% of the data fall between it. So 95% of the data falls within 2 standard deviations above and below the mean. And then lastly, if we go out 3 standard deviations, add 3 standard deviations above the mean, subtract 3 standard deviations below the mean, we end up with the boundaries for almost all of the data, 99.7%. Now, because that's true for all symmetric histograms that are bell-shaped, we can use this information to help us make descriptions about the data in regards to these particular percentages and the number of standard deviations. So let's look at what an example might look like. So, example, empirical rule. The calculator screen below represents average, or mean, and standard deviation for the U.S. Census Bureau projection for the percentage of the population age 65 and over for each state and the District of Columbia. The distribution is symmetric. So because they said it's symmetric, we know we can use the empirical rule. If they say it's a bell-shaped curve, we can use the empirical rule. Another word they might use is they might say that it is a normal distribution. We'll concentrate more on that when we get to chapter 6, but you may see it before then. But it represents a a symmetrical histogram. Okay, so pieces of the calculator that are important to us. First is the mean right here, and then the second is the standard deviation right there. We want the population standard deviation, not the sample standard deviation. Now let's look at the questions that they ask. What are the boundaries for 95% of the data, and what percent of the data falls between 11.566 and 14.932? So let's focus on the 95% of the data. So let's go back real quick. 95% of the data is within 2 standard deviations of the mean. So you can calculate just those boundaries based off of this characteristic. However, if you'll look back at the example, there are 2 questions. Question 1, question 2. So what I find helpful sometimes is just to go ahead and draw the entire curve and label all the parts to it with the means and all the standard deviations going up 3 and down 3, and get all of the boundaries for all of them. That way you're ready to answer any question that they could give you. So here is a normal curve, and in the center we have the mean, which is 13.249, I believe. 13.249. Okay, and the standard deviation is 1.683. All right, so what we're going to do is we're going to add 1 standard deviation. So I'm going to add 1 standard deviation. I'm going to add 1.683. So if I add 1.683 in my calculator, 13.249 plus 1.683, we get 14.932. That's a 3. Oops. Okay, so 14.932 is 1 standard deviation above the mean. Now we also need to go 1 standard deviation below the mean, but sometimes I think it's easier just to do all the addition first. So we're going to add, so here we are in the center. Oops. There's the center, and here's the upper boundary for 1 standard deviation above the mean. So then if I add 1 more standard deviation, I'm going to add 1.683 again. I'm going to get 16.615. Now I'm going to add 1 more standard deviation. So I'm going to add 1.683 again. And I'm going to get 18.298. Okay, so we've gone up 1 standard deviation, 2 standard deviations, 3 standard deviations above the mean of 13.249. Now, we also have to go the opposite way because it's within so many standard deviations each way, each of those properties. So we need to go down. We need to go down a standard deviation from your 13.249. So if we, oops, so if we subtract from 13.249, and instead of adding, we subtract 1.683, we get 11.566. If we subtract another standard deviation, we get 9.883. And then if we subtract 1 more, a third one, we get 8.2. Okay, so what does this tell us? So if we go down 1 and up 1, that's 68% of the data. So 68% of the data falls between 11.56 and 14.932. Then if you go up 2 standard deviations, you go up, so you go down 2 and you go up 2, those boundaries are 9.883 and 16.615. That is 95% of the data. And last, if we go down 3 and we go up 3, these two boundaries are almost all 99.7% of the data. So 99.7% of the data falls between 8.2 and 18.298. So if you'll remember, the first question was what percent of the data is within 95, or what boundaries are within 95% of the data? I'm saying that wrong. Let me just read it out so I say it right. What are the boundaries for 95% of the data? So 95% of the data is between 9.883 and 16.615. So this just kind of shows you how to do it by hand instead of drawing out the whole thing. If I subtract from 13.249, I subtract 2 standard deviations, so 2 times the standard deviation, and I add 2 standard deviations, 2 times the standard deviation, I get 9.883 and 16.615, just like we got there. Now, look at the next question. What percent of the data falls between 11.566 and 14.932? So 11.566, 14.932, that's 1 standard deviation each way, which is 68% of the data. So 1 standard deviation below and above the mean makes up 68% of the data. And as long as they were asking questions about 1, 2, and 3 standard deviations above and below the mean, you should have no problem answering the questions. This slide here just goes and shows you the same numbers that we got over here, right there, in a much nicer font, obviously, than my trying to draw on a computer screen. But you'll see 1 standard deviation is between 11.57 and 14.93, which is 68% of the data. 2 standard deviations between 9.88 and 16.61 is 95%, and 3 standard deviations, 8.2 and 18.3. Now they did round. I think we went out to 3. They went out to 2 for each thing. And there's their graph, which is much neater than mine. But that kind of shows you. Now I do want to show you this especially when you're doing some of the homework questions. So if you'll see 68% of the data is within 1 standard deviation below and 1 standard deviation above. But sometimes they split that and they'll say 34% of the data. Well, if you know 68%, half of that is from the mean to 1 standard deviation above or below. So 68% is made up of 34% below and 34% above the mean, 1 standard deviation each way. You can do the same thing with 95%, splitting that in half if you're going from the mean specifically. 99.7, you can split that in half as well. So that there could be questions about that. Those are definitely, they take a little bit more thought. So if you need help with those, please ask. Okay, so we're going to pick up with part 4 with this example about kittens.